Here's a great online option that you can use when you're calculating binomial and Poisson distributions. This is a nice option because it gives you the entire distribution so that you can see exact probabilities as well as your cumulative probabilities, and then you can pull all of the information that you need directly out of your distribution just as you need it. So let me show you how this would work if you're working in my stat lab. The website is vassarstats.net. So if you go to the vassarstats.net website that you see right up here in my address bar, /index.html, it's going to take you to this page right here, and then you're going to click on the distributions link over here on the left, and it's going to take you to this page. When you get there, you're going to have your options here. So let's say you need to work with a binomial distribution. So if you are in my stat lab, and let's say you have a problem like this one, and where it asks you to construct a binomial distribution for 34% of women who consider themselves fans of professional baseball. And you randomly select 6 women and ask if she considers herself a fan of professional baseball, and then you're to construct that distribution. You have an n of 6 and a p of 0.34. You need to find the probability of each of the x's 0 through 6. So each x represents that you have 0 women who consider themselves a fan, 1 woman considers herself a fan, 2, 3, 4, 5, and 6. So the probability for each of those values. So if you just take over here in this list and select binomial distribution, you're going to come to this page, and it's basically an explanation of what it's going to do, and you click continue. The page looks like it kind of goes blank, but don't worry, it's not leaving you. It's there. Now, it also told me that it worked best in Firefox, I think in Chrome. Internet Explorer wasn't listed, so if for some reason it doesn't show up and you're in Internet Explorer, I would close out and go to one of the other browsers. So the first value that it asks you for is your n, and in this problem our n is 6, and then I click OK, and I kind of like this function because it just asks me for one thing at a time and I don't get too overwhelmed with information. So I click OK, and then it asks for my probability value, and in this problem it tells me my probability value of success is 0.34. The probability of picking a woman who is a baseball fan is 34%. So then I click OK, and there's my distribution, which is great. It gives it to me in this histogram form, so I see it like that, and then I see it in my cumulative probabilities as well as my exact probabilities. So I have everything I need right there. And then up at the top, it even calculates my mean, variance, and standard deviation for this binomial distribution. So if you're just asked for binomial distribution, mean, variance, and standard deviation, you can even use this tool for that as well, even if you don't need the entire chart. So you could enter in your probabilities here. Let me see, let's make this window a little smaller so I can see what I need. So I need my 0.0827, I guess. It wants to 4 places. Is that what it wants? Actually, it only wants it to 3, so let's take that 7 out of there and make that a 3. And then we've got 0.255, and I'm hoping I get this right. I haven't checked this. 0.873. It's always a gamble when I do these things live like this, and I'm recording as I find my answers. Alright, so here we go. Here's my moment of truth. Oh no, I'm not correct. I wonder which one I got wrong. Probably typed, oh, that's the one. Let's see what I've got wrong. 0.0, oh, see, I did. I have a typo, which it happens. It was nice of the program to tell me which one I typed in wrong. 0.87. Now let's see if I'm right. Yes, that's great. Alright, so see, it was just a typo. Alright, so then, oh look, it tells me to graph it, and I have it already here on the screen. So this one goes ahead and gives me the information that I need. All right, so I could continue on with this problem and I could match up my graph with the graph that I'm given. Okay, so then that's how we would do that one. Now I'm going to go ahead and move on past this problem and show you how to complete a Poisson problem using this program. So let's go to question 15. So yes, we want to leave this problem. Okay, now here is a Poisson problem, and the way that I know this is a Poisson problem is because I'm looking for the mean number of errors in a interval amount of time. A newspaper finds that the mean number of typographical errors per page is 4. When you see mean number per something, when you see the words mean and per, you are looking at Poisson. Those are your keywords, mean and per. If you're looking at average in a unit of time, in an interval of time, then you're Poisson, and you can just move on from there. So in your Vassar Stats page, you just want to go back to Home and go to your distributions and pick the top, pick the second Poisson because you have a specified mean. And then it just wants the mean of the distribution. So it tells us that the newspaper finds that the mean number per page is 4. And we're going to click OK. And there it is. That's really all you need to give it. And it's going to give you everything you need. So the exact Poisson probability is given here in the first column, and the cumulative probability is given in the right-hand column. And then you can just enter in everything you need from here. So the probability of exactly 5 typographical errors per page is right here in the 5 row. So it's 0.1563. So let's type that in, 0.1563, and see what we've got. Good. All right, the next question is at most 5 typographical errors on a page. So that means at most I could have 5. I could have 5 or fewer. So you've got two options here. You can either add 5, 4, 3, 2, 1, and 0. You could add all those up yourself using your calculator, or you could look at the cumulative, which is the column in which it's already done for you. So when you get to this 5 row right here in the cumulative, that addition is already done, because that's what cumulative means. It's adding this one to this one and then writing it down, and then it's adding this one to this one and then writing it down. So when you get up here to this row, to the 0.7851, it's already added for you. So that's the cumulative up to 5, so 0.7851. And let's see what we've got. We've got that. All right, so the probability of more than 5 typographical errors on a page. Now, the probability of more than 5 is just going to be the complement of at most 5, because that's just going to be the rest of that probability. So you're going to take 1 minus 0.7851. So you want what's left over of that probability when you do that. So if you would just, in your calculator, just go 1 minus 0.7851, and I haven't done that calculation yet, so I'm going to do that really quick. 1 minus 0.7851, and see what I get. I get 0.2149. And let's see if that's correct. Yes. Okay. And the last question in this problem asks me if any of these events are unusual. Now, in order to be considered unusual, the probability needs to be less than or equal to 0.05. And if it is, then that is considered unusual. Okay? So if I have a value up here that is less than 0.05, it's considered unusual. This is greater than 0.05. So this is greater than, this is greater than 0.05, and this is greater than 0.05. So none of these are considered unusual. So I'm going to select none are considered unusual. And I've got that one correct. All right. So that is how you would work the Poisson distribution using that Vassar Stats tool. Find the indicated probabilities using the geometric Poisson or the binomial, then determine if unusual. Again, a major hurricane is a hurricane with wind speeds of 111. During the last century, the mean number of hurricanes to strike a certain country's mainland per year was about 0.63. Find the probability that in a given year, exactly one will strike the mainland. So again, you are introduced here to a problem that is talking about the mean number per year. Those are your keywords for Poisson. So I'm back over here on my distribution page. I'm going to pick the second Poisson distribution. The mean is given as 0.63, and I'm going to click OK. And I'm right back to where I was before. There is my distribution. So exactly one hurricane strike is going to be right here in this first row, 0.3355. And I'm going to check that answer. Oh no, it's not correct. I wonder what I did wrong. Well, I hate it when I don't follow directions. It's 336. It says to go to 3 decimal places. And there we go. So that can happen. All right. So anyway, I'm running out of time here on my recording, but this one is completed the same way the one we just did on number 15. So email me if you have any questions, and try to follow directions better than I did, and round to the appropriate number of decimal places.